Okay, thank you everyone for bringing me over to New York. Sorry for bringing the British weather with me. This is my first time in New York, and I noticed it's a bit different because as anyone who watches UK, what's it called? Yeah, that's it. So I don't watch it. It's just for you people. Anyway, this is how we all live in Great Britain. Yeah, we all live in one of these. Anyway, I got very, very excited about coming here. I've got way too many slides, so hold on tight because I'm just going to go through them really quickly. I want to get to see the pictures at the end. But I was asked to talk, as well as bringing some case studies, to talk about the context in the UK. So some facts and figures. About 18% of all of the UK homes are social housing of one description or another. Like Bomi said, a real mix of different types. It's about 5 million homes in total. So not very much in your context, I suppose, but it's still quite a large proportion. About 40% of those are local authority owned, so by the city councils. The other 60% are owned by not-for-profit housing associations, which do the same job, but they're often registered charities. And all those rents are set by the state. They have tended to be about 50% of whatever the open market rent is, but now we have new affordable rents, which are 80% of the market. So that's some good spin there by the government. And of course, that's putting a lot of pressure on low-income families to such extent that actually most of their rent has to come from the state anyway, from the welfare state through housing benefit. So here's an extreme example. This is Westminster in London. So $1,000 a week for a 3-bedroom property means that this is not even middle-income families being able to afford that. So it's actually costing the state a lot of money to house people because of this linkage to open market rents. And open market rents are just going up and up because we have pressure on households. We're not building very much anymore. So all of this is creating a bit of a housing bubble. And at the same time, all these buildings, 50s and 60s buildings, they're all getting older as well, and they're costing more to maintain and keep going. So this doesn't click forward like it does at home. Never mind. So yeah, we also talked about previously that the assumption was that, well, in the UK we have all this funding for retrofit, but actually we don't so much anymore. True, in around about 2000 we used to get a lot of funding under a scheme called Decent Homes, but that was largely geared towards a bit of cavity fill insulation, but also mainly towards modernising kitchens and bathrooms. That's still trickling along now, but doesn't really happen to the same level. We used to have schemes called CERT, CESP, ECO, energy reduction targets, energy saving programs, energy company obligations. So they were focused on energy efficiency, but not what I would call really deep measures. This was like, how can we do all the easy stuff, but not really worry about all the difficult bits? And the problem for me was that this was being funded by the energy companies. So you start to wonder, actually now I do realise why they don't want to do this properly, because it's in their interest to have customers after having carried it out. And they've done their job, their lobbying very, very well, because now that whole programme is terminated. So we have no funding really anymore. We tried something else called the Green Deal, which was a pay-as-you-save scheme. So the savings you get, the retrofit is paid for by the drop in energy bills, and the difference you then use to fund a loan that paid for the retrofit in the first place. The problem there was that the interest rates set by the government were just putting people off, and it was tended to be geared towards more owner-occupiers, but they just weren't willing to invest. It's cheaper at the moment to just take out another mortgage than it was to go through that. So the Green Deal has now been cancelled. So any refurbishment that is done now by councils or housing associations just has to be funded from the guaranteed future rental income. So the challenges are, we've got about 20 million homes to retrofit across the whole country, but this is some of the oldest housing stock in Europe. They're all pretty poorly insulated, they're all leaky, and they account for nearly a third, just the homes count for a third of our UK energy use. And we have the same problems. We have all these heritage and planning constraints. That means a lot of buildings we're not allowed to alter the external appearance of them. We have disincentives like VAT, value-added tax, costs 20%, whereas for building new homes, there's no tax on that. So it's disincentivizing refurbishment. And it's just really difficult doing retrofit, especially if you're trying to do it with people living in the buildings as you go. And a lot of our housing owners, they don't really understand building physics. They just want easy silver bullet solutions, but they don't really exist. The other problem we have is leaseholders in buildings. We had a scheme whereby tenants of council housing were able to buy their property at a discounted rate. They now want to extend that to housing associations, and they're talking about $150,000 discounted rate off the market price for their flat or house. So a lot of people are going for that, but it's reducing the amount of stock. It means you've got owner-occupiers in the same buildings as tenants, and they have very different wishes and hopes for retrofit. But we've got to do it. We've got a problem. We have a problem with affordable warmth. We still have around 25,000 excessive winter deaths every year from cold. We have air quality problems. We have high levels of asthma. We have all of these mold issues that have come about largely because all of these district heating systems have become obsolete and have been turned off. So we have individual heating systems in each flat, but to save money, people just don't use them. So then they get health problems. And as Bomi said, all of this is getting old. It all needs repairing. It all needs replacing. And then finally, we have climate change. Like New York, we have a UK commitment, 80% reduction by 2050. And climate. I don't have to tell you about climate change because I asked the Pope to have a few words about that last week. So I think we've covered that one. But I do want to talk about this woman. She's giving a talk this weekend on the other side of the United States. She's one of the authors from the Intergovernmental Climate Change Committee, Intergovernmental Panel on Climate Change. And I saw her speak at the International Passive House Conference a year or two ago. And she said that actually, if we're going to do retrofit, we should be doing retrofit, but it's a problem if we do it half-heartedly. We've got to do it once, and we've got to do it well. Every building retrofitted in a suboptimal way locks us into a high climate footprint future because it costs that much more to do the extra bits that we need to get to. So that's kind of where I start with clients, is saying, look, we need to do it, but we need to do it really well. It's not okay to do your little bit. You've got to do a lot. You've got to do that $150 one, not the $50 per square foot retrofit. Don't do things like this where, it's difficult to move that drain pipe, so we'll just insulate around them. I don't know if you can see that, but wherever there's a downpipe there, rainwater pipe, they just took the insulation around the outside of it because it was easier. So for me, deep retrofit, that means Passive House and Enerphit, which is the kind of refurbishment equivalent of Passive House. Super insulation, super airtight, heat recovery ventilation, a comprehensive approach, really detailed modelling. So if we're going to do that, where do we start? Do we start with all this traditional stuff? You call them row houses, we call them terrace housing. Well, I don't know, there are a lot of problems. They all have open fireplaces and chimneys, there's single glaze, sash windows, sliding windows, solid brick walls. Planners will never allow us to overclad on the outside of those, quite rightly too. We don't want to kind of destroy our cultural heritage at the same time. So I'm not sure this is the right place to start. I think you can do it. This has been done. One of those is a passive house. But you can't tell the difference. But is it affordable? Because you have to go to do special things like getting sash windows that are triple glazed, that open inwards and do all sorts of clever things. So it is possible, but it's probably right now not the best place to be spending the money. I think we should be focusing more on this sort of stuff, which is similar to what you were seeing before. This is a Thamesmead Estate. This is where I've been urging people to start. So, and it's not just because it's not just about retrofit. There's all these other things that you can do at the same time. You can deal with these fabric issues. Here's that brick facade peeling off the building on the 20th floor. A bit scary. So this is happening because these buildings are 50 years old. All the services need replacing. We have lots of problems with internal, external noise. They're all built next to dual carriageways, which are now really busy and very noisy. And everyone's complaining about the drab appearance of these buildings when they've had the nice, new, shiny, low-rise stuff. So we've got to do something about it. This is that same example I worked on afterwards. This wasn't Passive House standard, but this was overclad, replaced, new housing converted on the top. That's a 50 kilowatt peak solar wall panel there on the south side. So you can do it and kind of transform high-rise housing. Well, I thought this was high-rise. I can't call it high-rise anymore. It's only 24 stories or something. It's not even. Can't call it high-rise anymore. Anyway, this is the building I want to talk about. This is 11 stories. This is in Portsmouth, which is on the south coast of England. It's home of the Royal Navy. little island effectively. So this is post-war housing right in the centre of the city near the train station. 100 3-bedroom house maisonettes, duplexes, not sure the terminology. But lots of problems, lots of concrete, very poorly insulated, high bills. It's electric storage heating because the building can't take gas because of explosion reasons, progressive collapse reasons. It's owned by the city council, and they've got real problems and they're under a lot of pressure to do something about it. So their idea was, let's introduce a district-wide heating scheme that can do all of this block and do all of this area. Well, we better do a bit of insulation if we're going to invest in all of that. And that's how they went forward for it. This is the inside, this is the softer side, the friendlier side of that block. Still not particularly nice, lots of complications in terms of open walkways and balconies and sun spaces. You know, how do you start overcladding this? This was the challenge that we had. You know, all these bits of structure, if we did it conventionally, very, very difficult to deal with all the thermal bridging that causes. So I was working at another practice then when we started this, ECD Architects, and we pitched on the idea that actually, let's not do it. We're not going to offer what you wanted. We're going to suggest instead that you super insulate this building and don't change the heating system. Just leave the heating system, or maybe upgrade and improve the hot water storage. But let's do it quite differently, because we showed with diagrams that trying to deal with all this stuff and all the nooks and crannies and sun spaces is really difficult. We suggested instead super insulate the easy side and then create a new facade up the inside face, the courtyard face, that we could control much easier. And there's a lot of control. People didn't want to lose their balconies, they didn't want to lose their sun spaces, so we had to come up with solutions for all of these. And we spent a lot of time working with the tenants themselves, one by one, coming up with solutions to deal with all of their problems or their issues. So, you know, their problem was they can't afford to heat the space. Well, Enerphit will reduce that demand by 80 to 90%. They can't control the temperature. Well, the cladding can stabilise the temperature. They have all these mould problems. Well, we put in heat recovery ventilation. And one by one, we go through, we deal with all of the issues that they had problems with and turned it around and started to get real support. The overcladding strategies we had to deal with, they look simple. That looks like, yeah, big solid facade. We'll just pin insulation to the outside. Unfortunately, that's a bit of a cheat, because the outside face of that, this is a sandwich panel, unreinforced concrete, only 2 inches thick. And if we started pinning insulation into that as we would normally, it would just shatter. So what looked straightforward became more complicated. We ended up having to do an exoskeleton approach of steel nodes around the outside of the building to hold the building together, actually. The insulation holds this building together. These big blue structures look very strong. These big blue things, they look very strong, but they were sized just to carry their own weight in these balconies, and even adding insulation to them would have been too much. They're also not actually joined to the inside building. They just kind of sit there on their own. So our new structure had to brace either side of that and go right through into the party wall structures to tie it all together. But now the new steel structure holds everything together. And that's how we sold the outside for them. The cheapest way of doing overcladding in the UK is to put an insulation on the outside, pinned onto the wall, and then have a render finish over the outside. Now for me, that would have just recreated the same, you know, fairly bland facade. So we talked to them about, one of these is quite west-facing. We talked about the need for shading. They're kind of, you can always approach these buildings from different angles. So actually we talked about how if we use these fins to help with shading, we keep them on the north side anyway, but actually it just means that as you start to approach this building, you see it obliquely, you see different depths of colour. As the sun moves around, you get different levels of shading. So you get quite an animated facade from quite a boring window grid. And there's a kind of diagram of how we had to put steel on the outside, but we're putting a lot of insulation on the outside of here, a foot of insulation clad to the outside of this building, triple glazed, plastic framed windows. And that was our vision for the inside of that building. A bit more glazed here. We've got a lot of walkways, and for the balconies, we sold the idea of, well, we have an insulated enclosed balcony, but you can have windows that would open up, and you still have a secondary insulated envelope behind the balcony so that they can use that for drying. They can use it as a balcony, but in winter you can close that off and it's all part of the thermal envelope. And they all picked the blue colour. That's the colours of the local Portsmouth City football team, soccer team, sorry. So yeah, I tried to choose the rival colours, but they wouldn't go for it. So anyway, we had to make this argument. Is this all affordable? Well, the answer is it actually came out cheaper than their scheme. Not by much, but enough. But the benefit was that the tenants' bills would go down by that 80%. They're the people that are win-win. It doesn't cost more for the local authority, but the tenants gain massively from this. View of that kind of balcony area. So they had to then sell it to their board, to their government, and they took the view that if they didn't the do nothing option didn't exist, it would become uninhabitable very soon. They were able to get very good rates on loans. They did the calculations. They found that the extra over to go to Enerphit paid for itself within 15 years. Plus then they sold all these other benefits about the health, the affordability. If you can afford to heat your house cheaply, then you're more likely to pay the rent. So they can save on rent arrears. Their operatives don't have to go in and scrub mould off twice a year. So there are lots of other benefits that we start to build into the picture. So where are we now? I actually left that architects. I designed that. I thought that was the end of my involvement of it. They appointed a contractor. I moved to a new practice. They appointed a contractor. The contractor said, we need an architect to see us through the delivery phase. So everyone said, oh, you should go and talk to Mark. So I've ended up working back on the same project again, which is good. The price has gone up a little bit as we've found more asbestos and we've got more involved in it, but it's around about $130 per square foot currently. But a lot of that's new. We're getting new flats. All of the ground floor is being converted into new flats, and every flat gets 75 square feet of extra space. So here we are at the moment. For anyone who understands PHPP, that's 19 kilowatt hours per metre squared. That's pretty low in terms of heat. Use British thermal units. No one in Britain uses British thermal units. The other interesting one, overheating, 0.1%. So this has been designed for cross ventilation so that it doesn't overheat, so we don't need air conditioning. I was interested to hear about your peaks being in the summer. Air tightness. One of our problems is our energy use is still quite high because of that use of electricity. We have dirty electricity. So that's something we have to work on. But here we are now. There's the exoskeleton going on. This insulation goes behind that, in between that. And on the outside, we've got a fibre cement board. So that's ready for its final layer of 4 or 5 inches of more insulation. Roxel, you call it over here? Rockwool? Roxel. So that's going on the outside. These are triple glazed Austrian windows, insulated frames, triple gasket, airtight, very high performance windows. Doing a lot of works with, everyone's living in this building whilst we're doing it, by the way. So we had to create these enclosures. We reduced the size of their living room temporarily, do a load of works on the outside, crunching off all of these balconies, all done with the residents living in situ. We extend that living room, enclose in those open walkways, and there's the new facade window being created. That's kind of where we are now. We have to fit in heat recovery ventilation, so we do that all in the ceilings, and there's a lot of that being semi-rigid ducting all going in, all at ceiling level. It's tight, but it just about fits. And that's the vision there of, these are all produced by my former colleagues at ECD, but that's the vision of how that should be by the end of next summer. I've got 2 minutes to talk about the other project. I'll have to skip loads of it, but I want to get to the pictures at the end. This is the building we're talking about, so a bit lower, 5 stories, 4 stories sitting on top of a car park. Pretty hostile urban environment, not exactly a nice street. This is one of the main streets through this part of London. Not exactly very nice. This is the other side, a bit nicer, facing the south. Everyone has an individual balcony, 2 stories of duplexes. Again, that car park. How can we make use of that space? Well, the scheme really, it's actually this building here, not there. But this is a big area. That's the River Thames at the top. It's just a very weird. It was designed because there was a risk of flooding. That's why everything's raised up one level. That's all gone now. We have the Thames barrier, so the risk isn't there anymore. So in PowerPoint, this was a really clever little bit where it showed you the shape of the building, which is complex. Then you see the 2 4 maisonettes, and this dropped down and to show you how we do. So what we're doing, we took a different approach. We're working with a German contractor to use prefabricated timber cladding on the outside. So we build the whole panel from inside to outside to the cladding. In this case, we're using German contractors because they'd done it before and it was part of a European-funded pilot scheme. So built in Bavaria, brought to site and lowered into place from the outside of the building. Click through that's more detail. That was my back of a cigarette packet sketch. what we got there? Some pictures. Oh, that's the factory, making the panels in the factory. So everything filled with cellulose, all the way through to cladding on the outside. So yeah, you can see the cross section through those, and they're literally bolted to the outside of the building. Can I just show the last few pictures? So that's there. Look, clad to the outside of the building. 4 days that took to put all of those on. Residents in situ again. Line the inside. Put in the heat recovery ventilation in the warm air ducted space. Cost of that was a bit more, $158 a square foot. But we got most of that is actually new space, new shops down at ground floor level. This is really interesting. We took the government advisor to see this, and he asked the guy. He said, "What's your heating? How have you managed to deal with the heating?" He said, "Haven't used the heating all winter." And that's how it looks now. New stair towers, new shops going in. Yeah, do it once, do it well. No raz tych. I'm Cornish, by the way, not